because you get to watch the greatest movie ever made for the first time. The Princess Bride. It's my favorite movie of all time. I found out something recently this summer. 25 things you didn't know about The Princess Bride. This scene. The scene right after this when Inigo Montoya fights the men in black, the sword fight, they're calling out all these words. Using Benedetti's defense against me, huh? Those are actually 14th century fencing matches they're referencing in that. That's how awesome the script was in that movie. They were using real, they weren't just making up words, which I thought they were. Actually using 500-year-old fencing matches in the description of that little soliloquy. Brilliant movie, if you get a chance. I think it just had its 25th anniversary last year. Yeah, wonderful movie. Wonderful. Anyway, regardless, I want to hear your guys' guesses on this. Now, I want to take some guesses first. Did anybody say 7 point something as their guess? 6 point something? Got a 6 point something? Anybody do 5 point something? Got some 5s. Any 4 point somethings? Any 3 point somethings? Anybody below 4? So 4 point somethings with a low bound. Okay, good. We'll get to you guys in a second. Any 8s or above? No. 7s? 6s. So everybody's between 4 point something and 6 point something. Is anybody not in that range? It's okay if you are, just let me know now. Okay, so everybody's between 4 point something and 6 point something. This is the most concise data I've ever had. This is actually pretty cool. So what this is a stem and leaf plot. Sometimes just call it a stem plot. Sometimes just call it a stem plot. And you guys perfectly described, now this is ridiculously inane data. But you see how one aspect of your data is extraordinarily concise? The first number that you pick, the 4 or the 5 or the 6. But then the other aspect of your number is widely varied, the 0.0, 0.1, 0.2. One variable is tight and one variable is looser, which means it's nice to compress the tight ones and let the loose ones be as big as they need to be. That's where a stem plot comes in handy. And it seems to work pretty well with this data that I show you here. So, what I want to do now is I'm going to make up I make these horizontally because it's easier for me to read left to right than down to up. We're taught that way in school. So what I want to do now is, I'm going to say who guessed 4 point something and just throw out your guesses. 4 point. 6?
3.
9? 3?
4.
4? 4? 2 4s? 5? 5s? 3?
6.
6? Excellent. Is that everybody for the 4s? So what I've done is, instead of writing the 4 every time, it gets borrowed for each data point. 4.6, 4.9, 4.3, 4.4, 4.4. Some textbooks say they have to be in order. I don't give a crap about that. What I care about is that they're scaled properly. I'll see what I'm talking about right now. Who said 5? 5 point what?
0.
5.0? 3. 3. I heard 3 3s.
8.
8? That's it? Okay, good. And 6 point somethings.
0.1.
0.1, 0.6,
0.5.
0.5,
0.6.
0.6. Is that everybody? Some people didn't vote, totally fine. Totally fine. It's totally fine. You get the point of when you see it like this. Now, when I said that to scale properly, technology will do this for you. But you see how each number takes up the same amount of space horizontally? Do you see the histogram? Do you see the histogram? Turn your head 90 degrees this way. There it is! You see that? There's your histogram. Now you can make it vertical. I just read better that way. The beauty of this is we take care of Aaron's concern about the lack of precision of the individual data. It's like a way of getting raw data and the histogram all at the same time. Because the data are in there, yeah? This works real good for you natural resource people when you're out in the field taking measurements. You can write these down really quickly on your notepad and then take them back and put them in the computer later. Or take a cell phone picture and upload it and whatever you need to do. But it's really slick when you're in the field taking real quick data measurements. But it has to make sense. If these data points here went from 1 to 100, and these data points went from 0 to 10, you might not want to do this because you're not really saving any effort by doing that. So you have to have the right kind of data, compressed in one dimension and stretched out in the other. Now, you're going to know how to do that right now? No, that's not the point. The point is not for you to know that right now at this moment. I'm trying to give you as many different applications of histograms as I can think of. And this is a great one for natural resource folks. I got another great one for natural resources folks too, and this is a